Assalamu alaikum. We are going to start a new topic today. So this is just a subtopic of integration. So the name of the new topic is definite integrals. So the previous topic that we covered in the last two videos was called indefinite integrals. So this is the topic we have covered so far. So how do we understand the difference? You can understand the difference by looking at the symbols carefully. So remember, so far the integrals we saw had this particular symbol. So what's important to note here is there are no numbers attached to the integral sign. So for example, sometimes you might see numbers. So for example, 1 and 5 attached to the integral sign. So if you see numbers like this, then it means we have a definite integrals. If there are no numbers, then it means it's an indefinite integral. So that is one of the difference. You must remember and you must be able to note this. But the rest of the symbol looks the same, but still there are some subtle difference. So the other difference is in most cases, in the definite integral, this particular function here, the integrand, is the original main function. So please remember this and note this down. So this particular integrand will be the original function in most cases in case of definite integrals. However, in case of indefinite integrals, remember, in most cases this particular integrand is the derivative. So that is another important difference. So this is the derivative and this is the original function in case of definite integrals. So the other difference lies in the interpretation. So the next difference lies in the answer. So remember, in case of indefinite integrals, which we saw in the last two videos in the last week, the answer gives you the original function. You should remember this. So remember, this is the answer we get using the rules of integration, and this particular answer in most cases gives you the original function. So this is true for indefinite integrals. So what about definite integrals? So let's first of all try to understand how to find out definite integrals. How is it defined? So first of all, in case of definite integrals, you're going to see numbers attached with the integral sign. So this is a number and this is another number. And then you have the integrand, which is the original function in this case. So how do we find the answer? So the first step is exactly or almost the same as this step. So in the first step, you have to apply one of the rules of integration and find the integral. But you don't have to bother about the c, the constant of integration. You don't have to worry about this in case of definite integrals. So just ignore the c and then accommodate the values attached with the integral sign. So represent these values using this symbol. So why are we using this particular symbol? Please understand, when you find this integral, that means you have finished integration. So you cannot use this symbol anymore. Integration is complete. So how to account for these numbers here? How do we show them? Well, we show them using this particular symbol here. So just represent the numbers a and b using this particular symbol. So in the next step, so there is one more step. So this is another difference. In case of indefinite integral, the math ends here, right? This is it, you're done. But in case of definite integrals, you need to perform one more step. So in the next step, put the value, the higher value b, the upper interval, into your integral. So in place of x, let me use a different color here. In place of x, put the higher value b. So that is what we are doing here. And then in place of x, put the lower value a. So now put the lower value a in place of x, in place of this x, and then just subtract. So this is just the value of the integral at the upper interval at b, and this is just the value of the integral at the lower interval at the lower number a, and then you just subtract. That's it. And this is your final answer. So this is the definite integral. So this is how definite integrals are defined mathematically, and this is how you find them. So you can see there are quite a few differences. So let's move on to an actual math and try to understand what does the definite integral actually give us. So in the next video, in the next topic, in the same video, in the next topic, we are going to try to understand what is the meaning of this. What does it really tell us? So just now we saw the formula for the definite integral. So this is how definite integrals have been defined. So please understand, this actually guides you. This is the guideline of finding definite integrals. So what is this particular guideline telling you? So if we have a definite integral like this, to find the answer, first of all find the integral, perform integration using one of the rules. Remember, in the last week, in the last two videos, we learned around 5 or 6 rules. You can apply them and find this particular integral. After finding the integral, put the upper interval, the higher value b, into the integral, and then put the lower value a into the integral, and then just subtract. And that is how you find definite integrals. So let's apply this particular instruction, let's apply this guideline to a particular example. So let's say we have a definite integral like this. So first of all, definitely, no doubt, this is a definite integral. Why? How do we understand this? Because there are numbers attached to the integral sign. So because of these numbers, we are sure it's a definite integral, and hence we should apply this particular instruction, we should apply this particular guideline. So what is the first step? The first step, the guideline, this particular step is telling us find the integral. Use integration, find the integral. So please remember, in this case we can apply the second rule because we have a variable and there is a power. So you can apply the second rule. Remember, power plus 1 divided by power plus 1. And then we need to accommodate the intervals using this symbol. So we represent the numbers using this particular symbol. So put that symbol and then put the numbers. As you can understand, we are going to get x cubed divided by 3. So that is the end of the first step. So that is the end of this particular step. So we are talking about this step, that is the end of this step. Now we move on to this step. So what is this particular step telling us? We are almost out of space, so let's see if I can move down slightly. So the next step is telling us put the higher value 4 in place of x, right? That is what the next step is telling us. So in place of x, put the higher value, everything else remains the same. Then put the lower value in place of x as well. So now put this 2 in place of x, everything else remains the same, and then subtract. So that is what you need to do. You can use your calculator to find this answer. Whatever you get, that is the definite integral. So you're going to find using your calculator that 4 cubed divided by 3 is 21.3. So 2 cubed divided by 3 is 2.7. As you can understand, the final answer is going to be 18.6. So the question is, what does this definite integral mean? What is the meaning of this answer? What is the interpretation of this answer? So that is the most important part, that is the application part. So please remember, this particular answer tells you the area under the original function. So please remember, this is the original function. So this is the area under this original function above the x-axis and in between these intervals. So let me help you understand this with the aid of a diagram. So let's just rewrite the answer in a summarized form. So we just found out this particular definite integral is equal to, so we applied all the steps and we found out this is equal to 18.6, right? That's it. So we are just summarizing all our information in one line. So please understand, this is what we found. The answer to this, the definite integral, is equal to 18.6, as you can see here. So we are writing that in just one summarized step. Now the question is, what does this mean? So please remember, this is the area of this particular function. So let's draw this function. So remember, x square is very easy to draw. It's a U-shaped curve. You learned in Eco 134. So x square looks like this. This is x square roughly. So this is the area under this curve but above x-axis. So it's under this curve but above x-axis in between these interval 2 and 4. So let's draw 2 and 4 first. So let's say this is 2 and let's say this is 4 here. So let's draw this imaginary line 4 at 4 and at 2. So this 18.6 is the area between these 2 points. It is between 2 and 4, above the x-axis and below this curve, right? So if you want, I can draw this, I can try to draw this a little more clearly for you to understand. So this is roughly x square, y equal to x square. So please remember, it touches the origin, it meets at the origin, only touches it. And next, draw the intervals on the graph. So 2 and 4 can be labeled here. This is 2 and this is 4. And then draw this imaginary line at 2 and at 4. So this particular 18.6 is the area between 2 and 4, above the x-axis. So the area is above x-axis and below the graph. That's it. So this particular area is 18.6. So that is the application of definite integrals. One of the applications, it can help us find area under functions and above the x-axis. So that's it for this class. I'll just leave you with a small homework or classwork. So try to find this particular definite integral. So try to find this and then try to provide the interpretation as well. So please pause this video and try to find this out. So let's see how to find this out. So please remember, the first step is to integrate this. The first step is to apply one of the rules of integration and find the integral of this integrand. So please remember, 1 by x is equal to ln of x. And now we can represent the intervals 1 and 3 using this symbol. And in the next step, please remember, you have to put 3 here in place of x. And then you have to put 1 in place of x. And then you need to subtract. So use your calculator, find this out. So if you use your calculator, you will see that the answer is 1.1. Now let's try to answer this question. What is the interpretation of this number? What does this number mean? So please remember, this is the area. So this is the area under the function, under the integrand. So this is the area under 1 by x, and above y, above x-axis, between the intervals 1 and 3. So please remember, the area is between the intervals 1 and 3. So you must mention that if you want to write the 100% correct interpretation. So this is the area under 1 by x, above x-axis, in between the interval 1 and 3. So let's try to understand this graphically. That will, I think, give you a much more better understanding. So please remember, this is the area under 1 by x. So let's draw the graph of 1 by x. So you might remember from Eco 134 or from some other basic math course that 1 by x looks like this. So this is the graph of 1 by x. So this is how 1 by x looks. So this 1.1 is the area under this graph, right? But between 1 and 3. So this area is between 1 and 3 under this graph and above the x-axis, right? So this particular area is 1.1. So both is important. You can write the interpretation using only words or using only diagram, but you must understand both. So that's it. That's the end of this particular topic. So please practice these from the website, from the book. Thank you for listening. Take care, stay safe.